In this video, we're going to give you both the differential equation and the solution, and your job will be to verify that this is a solution. And so we want to make sure that you recognize this is not the same as what we did in the last video, which was finding solutions. So in this video, we're going to start with the solution, and then we're going to take the derivative of it and show that the derivative of this solution is the differential equation. Okay, so the first problem on the board is to verify that 4 minus x squared under a square root is a solution to the given differential equation. So here's what we do. We start out by taking the derivative of the solution. And so we think of 4 minus x squared as square root of 4 minus x squared as 4 minus x squared to the 1/2 power. So using the power rule for derivatives, we get 1/2 4 minus x squared to the negative 1/2, and then we're going to multiply that by a negative 2x. That's the chain rule. All right, and so we are simply simplifying this, and so we've got a negative 2x in the numerator, a 2 in the denominator, and what we get is a negative x left on the top, and then negative 1/2 power. We're going to bring the 4 minus x squared down and take that to the 1/2 power, and really we have verified now by taking the derivative of the solution that this is the differential equation, and hopefully you can see that they are equivalent. Okay, great. Let's move on to one that's a little bit more challenging. And so this time I'm going to give you the differential equation 2y prime plus y equals 0. And here's the solution. Y equals e to the negative t over 2. And so what we want to do is we want to verify that this is a solution. Okay, so just like before, we're going to start on the solution, right? And we're going to take the derivative, so y prime is equal to, and so the derivative of e to the u is e to the u times u prime. So here we go. Here's e to the negative t over 2, and then the derivative of negative 1/2 t is negative 1/2. All right, and so let me clean that up a little bit. Let's go ahead and call that e to the negative t over 2 all over 2 with a negative sign in front. And so that is the derivative of the solution. So now this time it's not quite as apparent as it was last time that this is a solution. So what we're going to do is we're going to go back and replace the y prime with the derivative we found, and we're going to replace the y with the original y and see if we don't get 0. So now we're ready to work on the differential equation side. So we're going to take 2, and instead of y prime I'm going to put in negative e to the negative t over 2 over 2, and then I'm going to add to that what y is equal to, which is e to the negative t over 2, and what I want to know is that equal to 0? So nice thing here, these are going to cancel, and so negative e to the negative t over 2 and adding e to the negative t over 2, like terms, they're opposite, and they do equal 0. Okay, one more example, and we're going to do one with a second derivative in our differential equation. So this time we're going to verify that y equals x to the 4th is a solution of the differential equation y double prime minus 12 x to the negative 2y is equal to 0. All right? It may seem like a lot more complicated, but it really isn't. What we're going to substitute in here is not the first derivative, but the second derivative. So again, when we verify, we always start on the solution, and so the derivative of x to the 4th is equal to 4x cubed. We don't need that, we need the second derivative. So here we go again, that would be 12x squared. And so we're going to replace the y squared with 12x squared and replace the y with the original equation, and let's see if we get 0. Okay, here we go. 12x squared is the y double prime, and we're going to subtract 12 x to the negative 2, and instead of y we'll put in x to the 4th. All right, and so remembering our exponent rules, x to the negative 2 times x to the 4, we add those exponents, and sure enough, like terms, the opposite, they add to 0. All right, so that is verifying solutions to differential equations. Just make sure that when you verify, you don't confuse this with what we did in the last video, which was starting with the differential equation and doing the procedure of separating, integrating, and solving. All right, so I hope this video helped, and we'll see you in class.